Hello, my dear students. Hope all of you are doing well and maintaining good health. I am Dr. Smruti and I welcome you all to Etuson, Education for Better Tomorrow. It's a digital learning platform for Odia and English medium students. If you believe in quality education, then you are in the right platform. As in Etuson, we provide quality education which will definitely help you to build your career. Then what are you waiting for? Please download the eTuition app and enroll yourself so that you can avail all the facilities at your fingertips. So students, without wasting much time, let us start today's class. So today we are going to start with the new chapter, that is chapter 6, which is triangle. Okay, so you are already acquainted with this term right from your childhood. And if you remember, in the earlier class also we have learned many things about the triangle. So here in the first class related to triangle, we will learn about similar figures. Correct children? Are you all ready for that? So let us start. So as I was telling you in the earlier classes, even in class 9 also, we have studied the different properties of the triangle and quadrilateral, etc. Correct or not? So basically you are acquainted with congruency, right? So what is congruency? If do you remember that? So two figures are said to be congruent if they have the same shape and the same size. Correct or not? Hope you remember it. Okay. So in this chapter, we will study about those figures which are the same shape but not necessarily the same size. Two figures having the same shape and not necessarily the same size are called the similar figures, right? I will give you some real life example. Like there are certain properties by which you can say that this particular animal is a dog. So dog has certain features, right? So you will just find out the resemblance between the different dogs and you can say that okay, these two dogs are looking similar. Similarly consider the human beings, right? So in human beings also you will find out the certain features, you will match them and you will tell that you look similar like father and son, mother and son, father and daughter. Likewise, so you find some similarity and you say that you two look similar, right? The resemblances. So you find out the resemblances, you match them, match the properties, and then you say not necessarily because father and daughter they are not of same size, but you find out the features. Then you tell that they are similar figures, right? So that is how the concept of similarity is, right? So you find out some of the properties, you match them, then you say that two figures are similar to each other. So we will learn more about this in this chapter. So one more question for you. Can you guess how heights of mountains are measured? Can you guess what is the height of Mount Everest? Can you guess? One more question for you. Can you guess the distances of some long distance object like moon? Do you think that the distance or the height of the mountains like Mount Everest or maybe the distance from Earth and Moon, do you think that somebody has measured the distance by using the measuring tape? Is it possible to measure the distance by such a long distance by using measuring tape? Definitely not. So to measure this also, uh, what we have used is the concept of similarity of figures. Correct? So, in fact, all the sides and distances have been found out by using the idea of indirect measurement, which is based on the principle of similarity of figures. Similarity of figures. Okay? Let us learn more about it. Similar figures. So for that, I have taken all these figures. Now you find out what are the similarities in this figure. So coming to bit 1, so as you can see, all of them represent circle. Because what do you mean by a circle? A circle should have a center and it should have a particular radius. So all of them are satisfying. They have, although they are not having same radius, but they have certain radius with a center point. So based on those properties, you can consider that all of them represent circle. So on the basis of that, you can tell that all of them are similar figures. But what about congruency? Are the circles of same shape and same size? So for that you have to compare the radius of the circle. So as you can see, here there is a bigger circle and there is a smaller circle. So these two circles definitely are not congruent. Now you can compare this inner circle and and this circle. So this too looks congruent as the radius, but you need to measure to prove the congruency that whether the radius of this circle and that circle is same. If it is same, you can tell that these two particular circle are congruent to each other. Correct? But without any hesitation, you can tell that all these are circles and they are similar in nature. Same is the case in this second bit where you have taken all the squares. Now what are the properties of a square? For a square, all the sides, so square is a quadrilateral having all the sides equal to each other and all the adjacent angles is equal to 90 degree. So all of them is satisfying those two conditions, right? So all of them are square and you can tell that they are similar figures. But what about its congruency? So to prove the congruency, you have to check whether the sides of the square which is represented here are equal or not. If it is equal, then only you can tell that two squares are congruent to each other. So what I can observe is the inner square over here and this square is congruent to each other. But all of them are similar figures and they represent square. Correct or not? Then coming to the third bit. Here also you have what? You have triangles, set of triangles. As you can see, all the triangles are looking like these two sides are equal in all the triangles. So you can say that all of them are similar figures. But while proving the congruency, you have to check whether the sides are matching with each other or not. Correct or not? But based on some properties matching them, you can tell that whether these figures are similar or not. Correct or not? Children, hope you have understood. So all congruent figures are similar, but the similar figures need not be congruent. That means if you have proven the congruency, then without hesitation you can tell that the congruent figures are always similar. But you cannot tell that if the figures are similar to each other, they will be also congruent to each other. Correct or not? Yes. So now let us observe these photographs. So it is very famous photograph of our monument Taj Mahal. So what is your observation? So as you can see, this is the same picture, same photograph having different dimension, right? You have magnified version, so you have one large scale, one medium and one small scale, but all of them represents photographs. So you can represent the same photograph. So you can say that all these are similar figures, but they are not congruent to each other. Correct or not? So what can you say about the two photographs of the same size of the same person? So here we have taken Taj Mahal, whose monument it may deteriorate, but it looks similar, right? Over the age, it looks similar. What about a person? What about a person? Can you tell a person photograph at the age of 10 and the age of 40? Right? So can you tell there that for the photographs are similar to each other? You will find some of the resemblances, but you cannot confidently tell that the photographs are similar to each other, because it keeps on changing. Your face keeps on changing, all those things, right? So you cannot tell confidently that they are similar, correct or not? So two polygons of the same number of sides are similar if their corresponding angles are equal and their corresponding sides are in the same ratio. So these are the certain conditions which need to be satisfied to have similarity in between two figures. Right, children? So now, the same ratio of the corresponding side is referred to as the scale factor. So where you are finding out the ratio, or this is otherwise known as the representative fraction for the polygon. Okay, children? So now let us see whether these figures are similar or not. Whether these quadrilaterals are similar or not. Okay. So now you just see, check the angles. So angles, here the angle is 85 degree. Here also angle 85 degree. This is 70 degree. Here angle is 70 degree. Here angle is 100 degree. Here also angle is. So according to the first condition, the angles are similar. Second condition is the representative fraction, right? So now you check. Here side CD is 2.4. Here side SR is 4.8, right? So first thing we have already confirmed, angles are similar. Angles are similar. So first condition is satisfied. Second condition, now check the representative fraction. So what is SR divided by CD? That is 4.8 divided by 2.4, that is 2. Correct? Now what is your SP divided by AD? That is 4.2 divided by 2.1, that is again 2, right? Similarly, what is PQ divided by AB? That is 3 divided by 1.5, that is equal to 2. So your representative fraction is 2 here. Similarly, what is QR divided by BC? That is 5 divided by 2.5, that is equal to 2. So from this very clearly you can tell that ABCD quadrilateral is similar to PQRS quadrilateral. Correct, children? Hope you have understood. Now let us take these two figures. Now, can you tell that these two figures are similar? So, on the basis of angles, because all the angles are 90 degree, first condition is satisfied. But what about the representative fraction? As you can see, your CD by SR is not equal to AD by SP, right? That means you can try with the numbers, that is 3 divided by 3.5, definitely not equal to 3 by 3. So from this condition you can uh, clearly tell that these two figures are not similar figures. Although one condition is satisfied where all the angles are found to be similar, but the other condition is not satisfied. So you cannot tell that these two rectangles, so to say, these two rectangles are similar in nature. They are not, one of them is square, other one is a rectangle. Correct or not? So, let us take one more example. So, here you have two diagrams. One represents square, another represents your what? Rhombus. Now, again, based on, although here, first thing which is discarded is angles are not similar. Here angle is 90 degree. Here angle, of course it is not 90 degree, right? So first condition is also only not satisfied. What about the other representative fraction. So here the representative fraction is same. Like for example, you can see SR by CD, SP by AD, PQ by AB. In all the cases it is 2. So that means representative fraction is same. Proportion is scale is doubled. That means side is doubled. But what about the angles? Angles are not same. So on the basis of the angles, you can tell that these two figures are not similar. Correct? Thus, either of the above two condition, one that is either angle or the sides or the fraction or the representative fraction, both the conditions should be satisfied. If any one of them is not satisfied, you cannot consider the figures to be similar in nature. Thus, either of the above two condition has to be satisfied to prove that the similarity of the two polygons. Okay, so uh, both the conditions are required to prove that similarity of the polygons is possible. Correct, children? Hope you have understood. Okay, so this is the concept of similarity of figures, which was very easy for you. So in the next class, we will solve problems from your first exercise. Correct, children? So keep practicing. Thank you so much for your patient hearing. Hope you have liked this video. Please share with your friends. Follow us with in Instagram, Twitter, and YouTube. Please don't forget to download the eTuition app. Thank you so much and take care of yourself.